Welcome you all for the wireless communication lecture modules. Indeed, we're going to start our unit 3. Unit 3 is digital signaling for the fading channels. In that first topic, we are going to discuss about the structure of wireless communication link. Okay, in that we are going to discuss about the block diagram of a transmitter and receiver, the entire generalized structure for a wireless communication. Okay, and then we are going to discuss about the black diagram for the digital transmitter and then black diagram of a digital receiver. So these are the contents which we are going to discuss about in this lecture. Okay, so this is the block diagram of a and both the transmitter as well as receiver. This is general structure for a wireless communication. So at the first we have a information source. Okay, so information source and then information source provides the information, and then we have a number of blocks. The top one which is at the top, that will be at the transmitter, right? And which is the thing which is at the bottom, that denotes the receiving end. So we'll discuss about each of the block and functionality of the each block. The first block is a information source. So normally the information will provide source will generates information and it will provides the information which has to be transmitted through the wireless communication link. So normally the information, either it may be a voice, it may be of video, it may be of audio or image. Okay, so whatever it is, the information initially will be in the analog information. Okay, so if you want to process the analog information, obviously for processing we must convert the analog signal into a digital signal. For that we are using a ADC in the information source. With the help of ADC, analog to digital converter, we are converting the analog signal into a digital signal, so that at the end of the information source block we are having a source information which will be in a digital format. So this is about the block one. It provides the information. Normally it will be in analog form. It can, with the help of ADC, we are converting it the analog into digital. At the end of the information source, we'll have a digital signal which has to be transmitted over the wireless block. And the second block is source coder. So normally the source coder is used to remove the redundancy of the information which is has to be transmitted. Okay, so why we supposed to remove the redundancy means the information which are not necessary or the information which are not taking into the consideration, that has to be removed, so that we can concentrate whatever the information which we are required. So that is called as a removal of redundancy. Why we supposed to remove the redundancy means to reduce the amount of source data that has to be transmitted, to reduce the number of bits transmitted, so for that we are removing the redundancy. So by the way we can save the bandwidth. So that is the concept of a source coder. It remove the redundancy so that it can reduce the number of bits transmitted has been reduced, so it should ensure that there will be a minimum bandwidth used to transmit the information. So that is the functionality of the source coder. And then we have a channel coder. The channel coder will, the source coder will remove the redundancy, but the channel coder will add some redundant information for the error correction and the error detection. Okay, so normally, in the wireless communication, the information has been transmitted in a free space. So there is a lot of possibility of that. Due to the interference and some other noises, the information may be the information will get into the error. So we have the possibility of the information by getting into the error. To overcome the error, there is a proper mechanism for the error detection and error correction. Okay, so for correcting the error as well as detection of error, this channel coder adds the redundant bit that will be helpful for the receiving end to check whether there is any bits has been changed or any bits has been error during the transmission. So that is the functionality of the channel coder. And then, so we will look at the digital transmitter so that we can have a detailed description of the above block. Okay. Then we have a signaling. So normally the signaling is used to establish the connection between the transmitting and the receiving end. Okay. So it is used to establish the connection as well as terminate the connection from the transmitting as well as the receiving entity. Okay, so this signaling is also used for the synchronizing the transmitter as well as a receiver. That is the functionality of a signaling block. And then we have a multiplexer. The data, normally data are transmitted as a bits. Okay, or bits and bursts. So for that a n number of data has to be multiplexed and it has to be transmitted over the channel. Even if you are using a MIMO, the multiple users transmit at the same time. So the information has been multiplexed together and transmits in a free space. That is called as a spatial multiplexing. That's a separate concept. We will discuss in a later part of the units. Okay. So here the multiplexing used, it converts the n to 1. That's n number of bits has been converted into a single thing, and that has to be transmitted over the channel. Okay, that is the functionality of a multiplexer. And then we are having a modulator, so the modulator will modulates normally the process of assigning a data bits into symbols. We have a data bits of zeros and ones, for zeros and ones it has to be mapped with the corresponding symbols. Okay, that process is called as a modulation. Okay, so the modulation will have a process of converting a also converting lower frequency signal to higher frequency signal by multiplying with the carrier, so as this signal moves to the higher frequency, then only the size of the antenna will be reduced. If you are using with a lower frequency, the size of the antenna has to be increased. So for our convenient, we are with the help of modulation, we are increasing the frequency of the antenna. Okay, that's also one functionality of the modulator. Okay, so it first maps the digits into symbols, and secondly, it converts with the help of carrier. It converts the signal to higher frequency signal. And then we have a digital to analog converter. Normally for the processing we will always use a signal in the form of digital. Okay, but for transmitting information to the wireless channel, that has to be an analog form. So at the transmitter end, after all the processing has been done, the signal has to be again converted back into the analog so that it can be transmitted into the free space. So for that we are using a DAC here. And then low pass filter, so low pass filter normally eliminates the spectral out of spectral components. Okay, it eliminates the out of spectral component outside the components which are outside the transmission bandwidth, that has to be eliminated. That is the functionality of a low pass filter here. And then we have a local oscillator as well as sub converter. The local oscillator will give us the unmodulated sinusoidal carrier, and that is multiplexed or combined with our input signal so that it can be up converted to up convert our input signal so that it can transmit it over a larger distance. So for up converting a signal, we are using a local oscillator, and that local oscillator provide a unmodulated sinusoidal wave. And then finally we have a transmitter filter. Already the low pass filter eliminates the out of spectral components, but after the low pass filter again we are up converting the signal, so after up converting the signal again we need to ensure that our signal is within the band of spectrum. Okay, so again the out of spectral components eliminated here. Here, this filter eliminates the out of spectral components that are occurred due to the upconversion. So these are the functionalities which are occur at the transmission end. So each black has a unique functionality, and each is doing its own functionality for upconverting the signal and transmitting the signal to the free space. So these are the block which we have discussed in this. Okay, next we are going to discuss about the components which are at the receiver side. Mostly the components which are using in the same side, that will be over here, and that will do the reverse process in terms of a receiving end. First we will have a RF filter. This RF filter will tuned along with the antenna will be tuned. Okay, so that the required band, it has to be adjusted with the required band so that it can receive the signal. That is the functionality of the RF filter. By adjusting the RF filter, we can receive the required signal or a signal which is of our interest. That is the functionality of RF filter. And then we have a low noise amplifier. So normally the signal has been transmitted into the free space, so once we are receiving the signal, that has to be always amplified with the receiver end. So here the low noise amplifier will amplify the signal so that it can be further processed. And then we have a down converter at the transmitting side, and with the help of local oscillator we are up converting this signal, here the reverse process. With the help of same local oscillator we are creating one more unmodulated sinusoidal wave, and it is used to down converted the original signal back. Okay, so that is the function of a down converter and a local oscillator. And then band pass filter. So band pass filter has to be set in set into the condition that so that our required area of interest, a lower band and upper band has to be set. So our required area of interest signal can be spectrum, required spectrum has to be gained. Okay, so for that we are using a band pass filter here. And then we have a automatic gain controller. So it amplifies the received signal, so we are converting up converting analog to digital, digital to analog. We are converting the signal into multiple times, so to remove the quantization error whenever we are going analog to digital, that's a one process called quantization. So quantization is nothing but it's a round off process. We are doing some round off during converting analog into digital. So round off is something nothing but we are adjusting the value. Okay, sometimes that error may occur. That error is called as a quantization error. To remove the quantization error in ADC, we are using a this automatic gain controller that has to be adjusted at the receiver side. Okay, and then again we have a analog to digital converter. So we receive the signal which travels in the free space, that will be analog. So we must convert the signal to digital for the further processing. So for that we are using a ADC here. And then demodulator, it is the reverse process of a modulator. Here we are map the zeros and one into corresponding symbols, again here now with respect to the corresponding symbols, we must get the inputs of zeros and ones. For that we are using a demodulator at the end. Okay, and then we have a demultiplexer. Demultiplexer is nothing but there we have combined the n number of signals into one and we have transmitted, again the signals has been divided into multiple signals. For that we are using a demultiplexer. It does the reverse process of a multiplexer over there. Similarly, we have a channel decoder and then source decoder. So normally, the source decoder will test the removal of redundancy. Here, the same thing, it adds some original information to get the original signal, so that is the source code decoder will add some the redundant bits which has been removed at the transmitting end. And then channel decoder, it has been used for the error detection and error correction. At the transmitter side, it has been transmitted. So with the help of the error detection and error correction, it used to compare the bits which are transmitted. It is in case of any deviation, that error has to be identified with the help of a channel decoder. Okay, so after that channel decoder and source decoder, we are converting the digital signal into analog signal. Okay, so the original information will be in analog form, that so it has to be converted into analog signal and finally it has to be provided with the receiver. So this is the entire process of transmitting information from the transmitter to the receiver. There are several blocks which can be used at the transmitter as well as receiver end. Mostly the blocks whatever we are using in a transmitter, and the receiver end, the reverse process has to be done. So the same block which has to be used in the receiver side, it will be in a reverse fashion. Okay, so this is the entire structure of a wireless communication block. These are the blocks which are required to transmit information from the transmitter end to the receiving end. Okay, so we'll just discuss the next topic in the next lecture session.